hope you're enjoying the class so far. I'm going to go through the PowerPoint here on Unit 6 just to kind of give you some lecture material. Hopefully this is another resource that's going to help you on this. Let me make this full size. So for Unit 6, we're going to identify the customary metric system units of measure. Hopefully you're familiar with that. And then we're going to be able to convert values between units of inches and millimeters, read fractional inch, decimal inch, and metric rules, understand the function and use of calipers, read standard and vernier micrometers, both inch-based and metric, and then understand the function and use of telescoping gauges and small hole gauges. You know, they use these last few, telescoping gauges and small hole gauges, and depending on the manufacturing environment, sometimes you'll use those, sometimes you will not. I think there's quite a bit of other manufacturing instruments that you might use more often, actually. But it's a good overview, I think. So within the U.S., they call it the U.S. customary system. Sometimes they call it the imperial system, the inch system. It is standard format in the United States for most manufacturing. The inch being the most common unit. I don't understand why they say most common unit. It depends on the application, is what it depends. If you're obviously, you know, if you're in manufacturing parts smaller than an inch or smaller than a foot, you're going to be using inch. And you actually don't even use yards that much anymore. And then you have the metric system, and it's often identified by SI, so International System. System International. And then it's got some prefixes here. These are really good to know. As far as a kilometer is a meter by factor of 1,000. So it's a kilometer. And then a centimeter is a meter divided by, it'd be 10 thousandths of a centimeter, as we would say it. And then a millimeter is 1,000th of a meter. So this, obviously, we really use millimeter in to divide the meter in the manufacturing parts are usually smaller than it's smaller than I don't have a good example, but we always use millimeter within manufacturing. And then they go over rules or rulers. If you've taken my 158 class, hopefully you have or you will. This is like one of the first measuring devices we use. And they say steel rule or scale. We often call this a scale. It's used to measure short distances and lengths. And then, of course, it's marked with graduations. I think any measuring device could be considered marked with graduations, except maybe digital ones, right? It's the fractional inch, decimal inch, and then metric. And then to read, you're going to line the one end of the object with the, I forgot, play a really good video where it kind of explains the end of the rule and how you can read from the end of the rule. And just obviously reading graduations from one end to the other. And these gives you some examples here, and these are actually really good examples. It shows the unit of measure here. This is 1 inch divided by 8. So graduations of 1/8. graduations by 1/16, and it gives some really good decimal examples here. And this one down here is graduations of 32 per inch, and it shows here 2432, which equals, it can be reduced to 3/4. So these are some really good examples. And then on this side, this is this isn't metric. This one is tenths of an inch. So this is still an inch rule. That might be a little bit confusing. But this is the scale you will probably use more, or as you get in manufacturing, engineering. To me, this is easier to read. When I use my scale, I almost always use this side of the scale, although I have what's called a 5R, and a 5R is typically, it's a design of a scale that has this on one side, and I think it's 32/64 on the other. So I have these two versions, one on each side. And then it's some good examples of the metric scale here. So the pro tip, and these are really good, this is a really good tip: set the rule as close to the object as possible. We definitely do this in the 158 class, and I show you when we're using the saw, or even when we're measuring from like the face of the lathe chuck jaws or something. And do not guess values. I don't know if that's, you certainly would never guess, but you don't, there's a time aspect of understanding your measurement needs versus how precise you need to be for a certain operation. But I do like that, you know, obviously don't guess values. And it says the 1 or the 10 millimeter graduations may provide more precision. And I'm not sure exactly what they're trying to say here on this. The 1-inch graduations, I don't know which. It's kind of odd. I'm not sure exactly what they're trying to explain. And then it goes through the calipers, and it gives some examples here. I honestly never used these. These calipers are used to transfer distances, and within the manufacturing, we're always using, we have measuring calipers, so we don't necessarily need to use transfer calipers. I've just never needed to use these. It's kind of funny that they would show these. They are used and applied in some instances, but in my experience in manufacturing and print reading, we just never use transfer calipers. And then this is a good pro tip regarding calipers and really other measuring devices. Just don't force it, and make sure the caliper points are at the same vertical location. So when you're using them, make sure that they're perpendicular to the workpiece and parallel to your view for the most part. And that's a good point. If not, the measurement may be too large. So if you're over the center of a diameter, but you're kind of crooked, you know, not perpendicular to the center line or the cylinder, if you're not perpendicular on both sides of the cylinder, you could get too large of a reading. You'll never get too small of a reading as long as you're over, let's say, the diameter of a piece, the correct diameter. And then it kind of talks about lining the points through the center. And then it goes through micrometers too. And I don't know why they just tell you measure with a fine pitch screw. All micrometers, all outside micrometers, have a pitch through screw thread of 40 threads per inch. Okay. And it goes through, I have a extra credit handout this week on that. So you can read that. It's actually one of the questions on the extra credit. So there you go. And then there's 3 characteristics. You have a They have a certain system of unit of measure. It could be metric, could be inch, and then electronic or manual. And then I'm not sure as far as standard or vernier. The vernier, what they're talking about is some of the calipers or some of the micrometers can read to a 4-place decimal. So they read to a 10,000th of an inch. That's 4th place decimal. I think that's what they're talking about. And then the outside diameters measure obviously diameters and part thicknesses on non-round parts or other features that are actually square. And then there's different ones. They're talking about inside micrometers too, which are kind of like, they call them bore gauges sometimes. And then there's also depth micrometers too that have the same screw thread, and you can measure depths. And then it goes through the reading of the inch base micrometer. Let's see, it doesn't go through, oh, it does go through the metric. I'm not so much concerned about this. Because this, I think if you get this, should be able to understand this. And then it goes through, the small hole gauges. But let's go through reading an inch base micrometer. Let's see. On the sleeve here, we have graduations from 0 all the way to 1 inch, right? And it's divided into 10 segments. So that this first line here is 100 thousandths, right? Or this first numbered graduation, 1, is 100 thousandths. The second numbered graduation is 200 thousandths. So they do the first reading. I think in the handout I gave you, it's a little better because the first reading actually should be 200 thousandths. And then for every line past the numbered graduation, you have 1, 2, 3. That's 25 thousandths. So it's 200 thousandths, 225 thousandths, 250 thousandths, 275 thousandths, and that shows that leader with the arrow to there. And then you would add the second or third reading, which is off of the thimble, which is shown here as 12. And you can see, if you hopefully in your book, I can't zoom in on this recording, but you can see there's between the line and the edge of the thimble here that rotates, there's an actual distance here, and that distance represents 12 thousandths. It actually is 12 thousandths of an inch. And then it shows here the vernier scale that I was talking about is to the fourth place decimal. And I don't think this is part of your homework on this. But you would do the same thing, add the vernier to the 6th place decimal, and wherever the thimble aligns on the other side of the barrel, as you have to rotate the micrometer around. And that's that's important sometimes, that you're able to lock the micrometer on the feature to be able to read the to the 4th place decimal. And then it goes through very similar for reading the metric micrometer. And then there's telescoping gauges. These are pretty hard to use. You really need, I don't say hard to use, but you definitely need practice using really all of these, but especially telescoping gauges, because there's a real trick to it. You compress the arms, you position, and you actually position slightly at an angle. See, it says compress the arms. It doesn't say lock the arms, so it can be kind of confusing. But what I'll do is I'll look up a YouTube video and I'll add a link to that so you're able to see this within the module this week. So, and I didn't do a PowerPoint demo on Mod 5 because hopefully that's again just review for you, I'm sorry, but if you have issues with that math concepts, and you struggle with that, just email me. And of course, email me about anything you struggle with in this course. And I'll get to grading, and please pay attention to the feedback, because that's really, I think, where you're going to learn. And I also want to emphasize on the tests, the homework from here on out, the homework and the quizzes are very similar to one another. As far as how the questions are worded, especially the homework. The homework, sometimes students really struggle with the homework because they don't really understand what the question is asking. So, and I'll, again, hand grade everything. Some of it, a lot of it I'll just give you credit for if I know you've understood the concept correctly, or I might eliminate some questions. But just when you do your homework and take the quiz, just make sure you're reading for comprehension and do your best to try and understand what they're asking for with the question. I think don't go too quickly through. Okay? All right, and again, reach out if you need help. Thanks.